everyone. Today we'll talk about a bit about. Sorry. Hello everyone. Today we'll talk about introduction to neural networks. But before that, a quick introduction about myself. I'm an applied research engineer with Ericsson and a PhD candidate working with industry partner. My PhD was fully funded by the Irish Research Council, and we generally focus on exploring new avenues in the anomaly detection with the help of how deep neural networks we can come up with the data-driven solutions, and most importantly, what is the research hot topic in the market is about how can we explain it, because the explainable part plays an important role. And along with that, I am experienced in analyzing data and providing insights by utilizing the domain knowledge to achieve the organization goals. So, the motivation factor why for me the PhD was to look into this specific area of neural networks. So, as we all know, the human brain is very complex and it has so much of flexibility, the functionalities that it can process lots of information. For example, we see a cat, we see a dog, and immediately will just come up with the answer that, oh, it's a dog, it's a cat. So how our brain is processing all that information makes me really curious. So wanted to investigate the same, how we can use that information, the same kind of functionality in the computer science world. So this is the motivational factor for me on how I started working towards the deep neural networks. So this is one of the famous AlphaGo game, and there's a very good documentary on Netflix as well, where the DeepMind guys based in UK, they try to explain that how with the help of deep neural networks they can follow and understand these complex patterns, what a human brain at times couldn't really analyze. And the beauty of the state of the art is the underlying the architecture, the algorithms makes it so good for us to apply in our day-to-day life. So AlphaGo is one of the driving factor for me to investigate more into this neural network space. So this is a very quick introduction. I wanted to give you how a neural network looks like, how we can use this in our coding world, and how does it look like basically. So as you see, there's an input layer, there's an hidden layer, and there's an outer layer. So input layer is nothing but the way we see the information, we see the buildings, we see places, and then these hidden nodes are kind of neurons, the synapses in your human brain, which tries to analyze the information, in which it tries to pass out that whether it belongs to category A, category 2, or category 3. So output node is nothing but the information your brain is trying to send out as a signal. And in all these neural network functionality, we have the concept called as the weights and the biases. Along with that, there's something called as an activation function. So activation function is nothing but it tells you how to process the information in terms of a signal. Either it's a yes or a no. So this is pretty much, being motivated. Again, I would say being motivated by the functionality of a human brain, of how it works. And guys, if you are really interested in knowing about this is the thing which I did in the starting of my PhD, was to um, follow the Coursera courses by Andrew Ng. He's really good, and he explains it to the core of how these each and every component of my weights, my different sets of input, whether it could be a image classification, it could be a video classification, doing some anomaly detection. It really takes you in detail. And most importantly, what our basic programming algorithms were not able to achieve is to capture the non-linear relationships we're able to achieve using the neural networking. So the training of the neural network like happens in this. It's a very high level overview again in terms of explaining that you have an input, then you have a layer called as a data transformation, because since we know that the data what we have, the raw data cannot be fed into as it is. So there's a saying in machine learning that garbage in, garbage out. So in order to avoid that, what we do is we do some kind of transformation. For example, if there's a text, if there's something symbol, so our machine does understand only the language of zeros and one. So we convert that into a data transformation layer, and then we train the model and get some predictions out of it. So what we do next is we have the model predictions and we have the true predictions. When we try to compare with the loss function, we get a loss score. The higher the loss score means the model is not able to learn. So what we do is we try to optimize the weights and the biases. What I explained in the previous slide back, that we have the nodes, we have the input nodes, we have the weights, and we have the biases. So this goes pretty much in an iterative way, just like a kid is reciting a poem, and it definitely doesn't learn everything in one go, but the more it learns, the better it proceeds towards achieving the target. So this is again a pretty much a partial derivative. The integration, what we have learned in our school days, is pretty much again applicable into this computer world again now. So not to take much more in detail, just to say that we try to optimize with respect to the error function, with respect to the weights, and try to optimize the network. And there's something called as a learning rate. So again, you know uh, if you ask any college teacher to teach a kid with that teaching capability, it definitely doesn't learn. It just goes back and forth. The same rule applies in the computer world also. The learning rate alpha, we call it as alpha, it's nothing but a numeric parameter like we define for the model, and we say that how slowly or how fast my model should be able to converge and able to learn what are my the true targets, and try to achieve the minimal of the loss score. So in our machine learning, there are different kinds of learning approaches, even with respect to the deep neural networks, which is the supervised learning, unsupervised learning. So here I'm trying to focus majority on the unsupervised learning because that's my pretty much topic of the PhD as well. Supervised learning, I would say that it's more of a teacher and a student approach, where a teacher will tell a student, okay, this is right, this is wrong, and this is the way you have to learn it. So it's kind of a you have a specific target labels associated with your raw data, like you have the apple class, like the fruit classification. This category of the raw inputs like belongs to apple or oranges or banana. But what if you have a mixture of raw data and you don't know what is the associated label behind it? In those kind of scenarios, this unsupervised learning plays a very important role. What it does is it tries to make the patterns out of the data and then tries to classify on its own. So what advantages it has is there's no requirement of labeling and less of human intervention, because most of the time, guys, really are being spent in just labeling the raw input, whether it's a good or any kind of classification. So in order to avoid that, this is one of the major approach, like major advantage of using an unsupervised learning. So once we are able to do unsupervised learning, so this was seen long time when I was a part of my industry, and when I came up with my results to my team that, oh, this is what I'm using a deep neural network for my anomaly detection, and came up with the very fancy terms of rock, then area under precision recall. Okay, this is my precision, this is my recall, this is my receiver operating characteristic curves, pretty much good in 90, 97, 98%. But were they really able to understand that why it is happening? So pretty much following the concept of how, why, when, who, what, and where, this becomes really important in the real life market, that I should be able to understand what my model is trying to learn. So how to make my insights easily interpretable is one of the state of the art research being conducted in the space of deep neural networks. So, when we investigated, there were a couple of model agnostic methods, pretty famous these days, called as a Shapley additive explanation. What it helps is instead of just giving the numbers of accuracy, precision, and recall, it adds on addition of explaining the model, explaining the output of the model. For instance, if you have a multivariate raw data, like you have multiple features targeting towards a specific output, I want to know what all features contributing in getting in achieving my target. So, for example, if you look at over here where we have age, sexuality, BP, BMI, and these are being given as a raw input to the model, and we say the output is 4, then what my SHAP algorithm will do is it will try to analyze, okay, my age was the majority of the factor in producing my output as 0.4, whereas my sexuality was lesser. So these kind of scores associated with each and every feature really helped in understanding whether my model is biased or not. So this was the example of if you're approaching towards some kind of supervised learning. What if you have unsupervised learning? So my PhD pretty much involved in investigating into unsupervised explainer. So in that case, we use a kernel SHAP where I'm trying to say that I have almost like 200, 300 feature columns, and I don't know whether these kind of columns, the values associated with it, will it be really contributing it to some kind of anomaly in my network or not. So guys, just to give you a brief introduction, my whole PhD was inclined towards the telecommunication domain, and they were pretty much inclined towards understanding that if there is any anomalous pattern in the network, in any kind of network call in the space, I want to know what all feature values contributed to it. So these kind of I use in particular autoencoders, which are really good in doing the high dimensionality reduction and explaining whether a particular row is particular set of feature values is anomalous. I want to know why it was anomalous. I want to know what values of the feature columns made it anomalous. So that makes it pretty much interesting rather than sticking all the time just to accuracy and the precision recall. I get a lot more insights, which I felt confident in telling this to my teammates, and obviously it helps the customer in the end to understand that if you are coming with this solution, I know pretty much what's happening in the background. So there's a couple of dissemination of work being published over on my Google Scholar account. You can have a look where I have published in one of the like few of the good conferences, and feel free to reach me out at LinkedIn. My LinkedIn link is over here. And happy Women's Day, all the beautiful ladies out there in IT. Keep it up and enjoy your day. Thank you.